Hello and welcome to section 3.4. Here are the solutions for 3.3. Let me know if you guys have any questions working with the converses. Okay, so 3.4 goes a complete other way. We've been working with proving lines are parallel or working with transversals. This goes back to algebra. So 3.4 is basically a lot of review for you guys. We've seen most of this either this year or last year. We're going to start with slope. This should be familiar here. Slope of a line is rise over run, or it is y2 minus y1 over x2 minus x1. Changed in y over changed in x. A lot of different ways to represent slope, depending on if you're given coordinate points or if you're given, say, a graph. You could do rise over run. If the graph goes up, that's positive. If the graph goes down, that's negative. Here is undefined. Let's see, undefined slope is any vertical line, and I'll show you why. It's undefined a little bit here. And then zero slope is this guy right there. So I'm going to do an example of each one of those, find the slope of each line. Let's start with the positive one, the green one. So we could do rise over run, or you can apply the formula. I'm going to apply the formula y2 minus y1 over x2 minus x1. So that slope is 3. And if you do rise over run, I did something wrong. Oops, I'm going to start over. Y2 minus y1 over x2 minus x1. I was like, something doesn't seem right here. 4 over 2 is 2. Okay, there we go. And if you do rise over run, you go up 2 over 1, up 2 over 1. And you see that you get a slope of 2. We'll do the blue one next. Okay, so that one we're looking at y2 minus y1, so 4 minus 2 over 6 minus 8, and that's going to give us 2 over negative 2, which is negative 1. So that one goes down 1 over 1, and you can check here, down 1 over 1. And could you just use the graph and do rise over run? Sure, but I just wanted to show you guys where these values are coming from. Let's move on to the red line now. That one should be our undefined slope, and I'll explain why it's undefined. So we have 4 minus 0 over 6 minus 6, and that's 4 over 0, and that's why it's undefined. Okay, so because we can't divide by 0. And then the green one, the other green one, it's a darker green, I guess. They're both kind of green, I guess. I'll just use yellow, I guess. No, yellow is a bad color. Let's try purple. Okay, it's a little bit better. Okay, so this one's going to be our 0 slope. So we have 4 minus 4 over 6 minus 0, and that's 0 over 6, which is why we get 0 slope. So horizontal lines are going to have a 0 slope. And you can use any point on the line. All of these slopes are going to be the same. And then this is something we've studied before. Slopes of parallel lines are the same, and slopes of perpendicular lines, their product has to equal negative 1. What you guys probably have heard is the term opposite reciprocals. I'm guessing you guys have seen this term. Opposite reciprocals. And what that means is if one slope is 2 over 3, the other one is negative 3 over 2. And what this is saying here, if you multiply the two slopes, they're going to give you negative 1. Their products is going to be negative 1. And you can see here you have negative 6 over 6, which is negative 1. So there you go. That's perpendicular lines and determining whether or not they're perpendicular. Finding each slope, which lines are parallel. So we just want to see which slopes are the same here. So I'm just going to do rise over run. 1, 2, 3, 4 over 1. So that one's 4 over 1. Should use a different color here. This one is 1, 2, 3, 4 over 1. Those are parallel. This one is 1, 2, 3. I'm going to go over here. 1, 2, 3, 4, 5 over 1. So this one's 5 over 1. So the red and the blue are parallel. So K1 is parallel to K2. And then here's a perpendicular problem for you guys. Line H passes through 3, 0. So 3, 0, and 7, 6. And it says graph the line perpendicular to H that passes through 2, 5. Okay, so here's 2, 5. So what I need to do is figure out what the slope is for this line here. So I'm going to go up 1, 2, 3, 4, 5, 6 over 1, 2, 3, 4. So this one's 6 over 4, which is 3 over 2. So that means my new slope, if it's 3 over 2, has to be negative 2 over 3. So I'm going to go down 2 over 3. And I probably should have used my line tool for this one here to show that they're actually parallel or perpendicular. Okay, I'm going to save that for class. This we don't need to do, and there is your assignment. I'm actually going to do this one. Oops. Oops, I need to, sorry about that. I'm going to do one of these with you guys so that you know how to do these. These problems I have marked as challenge questions. They're in your book. What they say is they give you one of the coordinate points. This is number 30. And they give you half of the other one. And they tell you what the slope is. So they tell you that the slope is negative 2 for this question. And your objective is to find the other coordinate point. So you can do this using graph paper, or you can use it using algebra. I'm going to show it using algebra in case the problem were to be a fraction or a decimal answer. So what you do is you apply the slope formula y minus y1, so y minus 2 over 0 minus negative 3, and you set that equal to what the slope is, so negative 2 over 1. I can simplify the numerator, or sorry, the denominator to 3. And now I have a proportion, and you can just use cross multiplication. So 1 times y minus 2 equals 3 times negative 2. 1 times y minus 2 is just y minus 2, and that equals negative 6. Add 2, and your y value is negative 4. So I'd give those other two a try. They're not as difficult as they seem, even though I'm marked as challenge. So thanks guys for tuning in to 3.4. Let me know if you have any